accessed at the same time every transaction. Okay? There is no transaction that access only employee. There is no transaction that access only department. All together, always. At that time, you don't have to separate. Even though that violate the first guideline, second guideline, third guideline, and also the function normalization, but you do better combine into one. That is called denormalization. Okay. So, first normal form. What is the first normal form? First, we have such an unnormalization, unnormalized table, unnormalized database design. Okay, check first each attribute, whether each attribute is composite. What is a composite? More than one attribute in one attribute, right? So like the address, if you consider the address as the combination of street number, street name, and state name, the town name, whatever, this bunch of attributes make one attribute that is composite attribute. We don't want such a composite attribute. What about the multi-value? Like the location. Locations. There are many locations for the project. So multi-value attribute. First, normal form does not allow multi-value. Nested relation. What does it mean? Table inside the table, which is not allowed in relational model. Actually, this is the limitation. Due to the limitation of relational model, that's not allowed. Okay? So first normal form does not allow composite attribute. Also multi-value. Also no nested relation. Okay? For each attribute. If there is no such a thing, that means this is the first normal form. Okay? Somebody may be curious. What about the object-oriented database? Object-oriented database, actually you don't need normalization process. All of these are allowed in object-oriented concept. But the nested relation, definitely that's the benefit of the nature of the object-oriented concept. You can use the class, right? Inherit. Also the multi-value doesn't matter. And the composite doesn't matter. Unfortunately, relational model is too strict, actually, to keep such a condition cases. So the relational model does not allow such an attribute. That is the first normal form. First normal form does not allow this. For example, is this the first normal form or not? Composite, can you find any composite attribute? No. Can you find multi-value? Yes, the location is multi-value. So this is not multi-value. I really for that at this time. Okay, so what about this? This is an example of the department. So we need address, such a problem. The only solution to make the normalization is, the segmentation. Segment, take out that part. So in this case, to make the first normalization, we can take out this attribute, make the new table. That is the reason it's called normalization, or segmentation, or decomposition. Another solution is rarely this one can be used, Okay. So this is the first normal form, but we will see why this is not. This is the first normal form, but not in other normalization form. How to solve that problem? We can take out that part. What about this? This is an example of the nested relation. You can see in the PR product attribute, there is a nested attribute. So this is not allowed in first normalization form. How to address that one? We can decompose. Take out. Then make the new table for projects. So we have the project 1, project 2, and project 1. 1 minute, 2 minutes, 1 minute for each normalization. So second normalization form. So in first normalization form, we focus on each attribute. Second normalization form, we will use the functional dependency. First, we need to identify minimal functional dependency. Then, second normalization form does not allow partial dependency. Partial dependency means one of the non-attribute column is determined by only this one. However, the other attribute, social security number and project number, determine ours. Right? And also P number determine only P name and P location. This functional dependency is part of first functional dependency. It's a partial dependency. So second normalization form does not allow such a partial dependency. Why? There's a different meaning. This one, they are different. This one and this one, they are different. So we don't want such a different meaning. And third normal form, sometimes functional dependency is not partial dependency, right? There's no partial, but social security number determine D number, and D number determine D name. What is this? X determine Y, Y determine Z. This is the X determine Z. This is called transitive. So in case you have transitive, that means it's a redundancy. So third normalization form does not allow such a redundancy. Transitive functional dependency. How can we solve the problem of the second normal form, third normal form? How can we make the higher level of normalization form? The only solution is segmentation, decomposition, separate. Okay? So we will see more examples in the next class. Thank you and see you next week.